In the world of automotive safety, few tests are as revealing as the Moose test. Designed to simulate an emergency maneuver, such as suddenly swerving to avoid an obstacle on the road, this procedure can expose critical limits in vehicle stability. Today, we analyze electric car models that did not perform well in this challenge, based on evaluations conducted by the specialized portal KM77.com. We begin with the smart number 1 Brabus. Far from living up to its high-performance promise, the crossover completed the Moose test at only 65 km per hour. This was the lowest speed recorded among the electric vehicles tested, attributed to a combination of low rolling resistance tires and inefficient electronic stability control calibration. Next, the BYD Han also showed difficulties. The full-size sedan exhibited a strong tendency to understeer, in other words, to resist directional changes. It failed to complete the maneuver at 77 km per hour, hitting the cones in the process. Another model that fell short of expectations was the Ford Mustang Mach-E. The SUV showed rear instability, slow steering response, and delayed activation of the stability control. As a result, it failed to maneuver at speeds over 70 km per hour. The Volkswagen ID.4, in turn, completed the maneuver at 73 km per hour. Its performance was limited by understeer and low-grip tires, compromising its agility. In the case of the Kia Soul EV, the test was completed at 68 km per hour, a below-average performance for electric vehicles. The model's compact dimensions did not compensate for its lack of structural agility during sudden direction changes. The Škoda Enyaq iV only reached 67 km per hour. This result was considered unsatisfactory, especially for an SUV of its size, revealing significant dynamic limitations. Among urban crossovers, the Mazda MX-30 fell short of expectations. It completed the maneuver at 74 km per hour, a modest mark by today's standards, especially considering its focus on safety and drivability. The Honda E, a compact model aimed at urban mobility, also failed to impress in the test. It reached 75 km per hour, a performance considered merely average. In the premium segment, the Audi e-tron Sportback showed limitations. Despite its sophisticated proposition, it completed the maneuver at 75 km per hour, below expectations for an SUV focused on performance and technology. Concluding this analysis, we have the BMW iX xDrive 40, which also did not achieve standout results. The maneuver was completed at 74 km per hour, a figure considered underwhelming for a luxury electric vehicle. These performances highlight the importance of the Moose test as a tool for evaluating dynamic behavior in risk situations. While these models may perform well under normal conditions, their failures in the test reveal significant limitations in emergency scenarios. On the other hand, a model that stood out positively was the Tesla Model 3. The electric sedan completed the test at 83 km per hour, an impressive performance that reflects a combination of factors. Its low center of gravity, achieved thanks to the battery placement, contributes to greater stability. The balanced weight distribution between the axles, combined with precise electric steering and effective stability control, ensures quick and safe responses. Regenerative braking also plays an important role, allowing for progressive and controlled deceleration. The Moose test remains a crucial reference for vehicle safety, especially in the context of electric mobility. The results observed show that technological advancement must be accompanied by effective dynamic engineering capable of handling extreme situations. If you want to keep following technical evaluations and in-depth content on the automotive world and electric mobility, subscribe to the channel and turn on notifications. See you in the next video.